So title is Rationalizing Denominators. So we started working on square roots yesterday, and so today we're going to have some more square roots. The difference today is there's some division, so there's fractions. So when you have a fraction, it is tradition in math to not let there be a square root in the denominator. So you can't have a square root downstairs. So as this is written, we're not happy with it because there's a square root in the denominator. So our job is to get rid of the square root that's downstairs. That's called rationalizing the denominator. Denominator is the bottom of the fraction. So we're getting rid of the square root in the bottom, which is called rationalizing the denominator. All right, so what I'm going to do is, don't write this, I'm going to multiply by 1. Why am I allowed to multiply by 1? Yeah.
Because even if you multiply by 1, the equation stays the same.
Exactly. The value's not going to change. If you take 7 times 1, still 7. So if I take this number and multiply it by 1, I'm not changing the value of the number. Okay, but the reason I told you not to write times 1 is we're going to multiply by a weird 1. There's lots of ways to write 1. For example, 4 over 4 is 1. Or 58 over 58 equals 1. So I am going to multiply by 1, but I'm going to multiply it by a weird looking 1. The 1 I'm going to multiply by is square root 6 divided by square root 6. So do you agree with me that that equals 1? Yeah, any number divided by itself is 1. And then the reason I'm multiplying by that is because of this square root 6 down here. So that's why I chose that. I didn't do square root 2 over square root 2, which would have been okay. But I chose square root 6 over square root 6 because of that. So then what happens is the bottom comes out to square root 36. Which is good news because then the square root of 36 is 6. So then I no longer have a square root downstairs. And that was my goal, to get rid of the square root in the denominator. Now, that makes the top messier, though. So the trade-off is, even though the bottom's getting better, the top then gets worse. So on top, we're stuck with 4 times the square root of 6. So we just multiplied across. 4 times square root of 6 is 4 square root 6. And square root 6 times square root 6 is square root 36. And like I said before, the square root of 36 comes out to 6. But the top is still messy. So I accomplished what I needed to accomplish. What I was asking us to do, which is called rationalizing the denominator, was get rid of the square root downstairs. And I did that. This original problem had a square root downstairs, but this doesn't have a square root downstairs. So that's called rationalizing the denominator. All right, and you can do one more thing because 4 over 6 reduces. It reduces to 2/3. So all I did from that step to that step is divide everything by 2 to reduce the fraction. Okay, here's number 2. 3 divided by the square root of 10. So I'm trying to rationalize the denominator, which means I'm trying to get rid of the square root in the denominator. So what should I do? Bless you. Yes, sir.
Multiply by the square root of 10.
Good. Well, it's technically multiply by 1,
Yeah.
and the 1 that we're going to choose is square root 10 over square root 10.
Yeah.
Awesome. You said the right thing. I just said it in my over-technical way, which I always say, right? So, again, this is legal because this equals 1. So all we're doing is multiplying by 1. It's not really changing anything. It's not changing the value. It's changing what it looks like, but it's not changing the value of it. And the reason we chose 10 is because the square root of 10 times the square root of 10 is the square root of 100, which comes out to plain 10. And then we can multiply across the top. That's 3 square root 10. And that doesn't get any better. So final answer is 3 square root 10 over 10. This time the 3 over 10 doesn't reduce, so we don't go to another step. All right, now we've got 96 over root 2. So we're going to multiply by root 2 over root 2. So that comes out to 96 root 2 over root 4. And then the square root of 4 comes out to 2. Everybody doing okay so far? And then 96 can be divided by 2. So that comes out to 48. So the original number was 96 divided by the square root of 2. And the final answer is 48 multiplied by the square root of 2. Someone with a calculator, would you be willing to divide 96 by the square root of 2? If you have a calculator, it would be good for you to see this. If you don't, that's okay. But so just type in 96 divided by square root 2. Comes out to some big nasty decimal, right? Okay, now on the next line, multiply 48 times the square root of 2. Did you get the same thing? You should have, because remember, we didn't change the number. We multiplied by 1, so we didn't change. It just looks different, but it's the same value. So 96 divided by the square root of 2 is the same thing as 48 times the square root of 2. Same number, just written in a different way. Okay, then this goes back to what we said yesterday. Why are we leaving it like this? Why aren't we writing the answer? Like Taylor and Rachel had a decimal on their calculator. Why aren't we writing that decimal? Yeah. Because it's annoying, because it fills up the entire screen. So in science class and in math class, we deal with this issue in different ways. In science, they say just round it, which is good because then you can see what the number is, right? But the problem that the mathematician has with that is it's not exactly right. So then in math, we say, well, let's write down the exact right answer. And that's this. So this is better because it's exact, but it's worse because you can't tell what number it is. So there's good and bad to both approaches. Rounding is a nice idea because you can see what it is, but the downfall to that is it's not exactly right. So the scientist and the mathematician choose to do different good things and different negative things. There's good and bad to both is what I'm saying. Okay, number 4 is 5 divided by the square root of x. And remember, what we're doing is called rationalizing the denominator. So we're trying to get rid of the square root downstairs. So what should I do on this one? Yes, ma'am. Yeah. So multiply by 1, and this time the weird form of 1 is square root of x over square root of x. So then the top is 5 square root of x. The bottom is square root of x times square root of x would be square root of x squared. Because x times x is x squared. And then what is the square root of x squared? Yeah, just plain x, right? Because the square root and the squaring cross each other out. Okay, the next problem has a cube root in it, so I want to go off to the side and just remind you what a cube root is. So the cube root is when you have the radical symbol, but with a little 3. That's called cube root. So let's think about the cube root of 27. What this means is what times what times what is 27. So that's different than square root. Square root means just 2 numbers, 2 blanks, right? What times what is 16? Well, of course, it's 4 here, right? So here we're saying what times what is 27. So what is that? 3. Okay, so the cube root of 27 is 3. Because 3 times 3 times 3 is 27. All right, so 5 has a cube root in it. That's why I wanted to remind you about that. So we have 3 divided by the cube root of 2. And we're still rationalizing the denominator, meaning we're trying to get rid of the root that's in the denominator. So I feel like if I asked what should I multiply by, don't write this down. I feel like people would say the cube root of 2 on the top and bottom, just because that kind of fits the other problems. The reason that doesn't work is then you get the cube root of 4, and what is the cube root of 4? Is there a number that times itself 3 times is 4? There's not, so that's why we don't want to multiply by the cube root of 2 here. We need it to come out nice, right? So we need to multiply by something that'll make it nice. So any ideas on what I should put here? I'm making you think a lot. Sorry about that. Yes. Nice. If you put a 4 there, then it's going to come out to the cube root of 8, which is nice. And then you put a 4 on the top also, right? Because that equals 1. So then if I multiply by 1, I'm not changing the value. So that'll come out to 3 times the cube root of 4 over the cube root of 8. And then the cube root of 8 means what times what times what is 8. So of course that's 2. So that's what Bray was seeing. She said multiply by 4 so that we would get an 8 here so that it would come out to 2. And that's as far as you can go. Okay, so the topic today, the new topic was rationalizing the denominator. That means you need to get rid of the square root in the denominator, or the cube root, whatever root it is. Okay, now we're going to shift gears, and the next problem is going to say solve. So this is x times x minus 24 equals 0. All right, so to help you see what's going on, I'm going to underline this x, and I'm going to underline the x minus 24. What's happening with those numbers that I just underlined? Are they being added or divided? Multiplied, good. And the way to multiply is to distribute. You're right, Matthew. But the symbol that I could put in there is a multiplication sign. It's not being added, it's being multiplied. Okay, so I'm trying to point out to you that what's going on here is there are two numbers multiplied together. And when you have two numbers multiplied together, if just this one was 0, then you wouldn't care what the first one was. Because even if this one was 58, 58 times 0 would come out to 0. Or even if this was 97, 97 times 0 would be 0. So what I'm saying is, if this number was 0, it wouldn't matter what the first one was. And it's also true vice versa. If this number was 0, it wouldn't matter what that one was. So when you have two numbers multiplied that equal 0, you can just set them separately equal to 0. We've done that before. It's called the zero product property. So this one's already solved. X equals 0 is our answer. Here you just add 24 to both sides. So there's two answers on this problem. One of them is 24, and one of them is 0. If you plug 24 in up here, you'd have 24 times 24 minus 24. But 24 minus 24 is 0. So you'd end up with 24 times 0, which is 0. So we figured out the number that would make this true. And 0 would also make it true. All right, so you'll start with number 7.